Okay, so I'm Dean Hintz. I'm been with SAFE for longer than I'll admit, and I'm the product manager for Open Standards. At least that's one of my hats that I wear. So we'll talk a bit about our approach to cloud native. I guess I will probably have to introduce FME at some point. And then I'll run through kind of what we support and then look at some applications. And one of the disaster climate resilience pilots has a scenario based in New York City. And then we'll look at where we're going. So maybe I should have put a product slide near the top to say who we are. So FME stands for Feature Manipulation Engine. It's a data integration automation platform, and you'll see some screenshots which show it's essentially like a no-code environment where you can drag and drop different data sets and transformation steps and get the output you want. There are some kind of unique considerations when you're talking about cloud and cloud services, and I'll get into that later. First, I just wanted to put a plug in for organizations like Cloud Native Geospatial Foundation, who organized this whole conference, so kudos to them for bringing us all here. We're also very active with the OGC, Open Geospatial Consortium. A number of cloud native formats are community standards with them, and then Building Smart and others. I was going to put ISO down, and I was told I'm not allowed to, so we support quite a range of standards. And so standards, I think, are all of our friends. Basically, it helps us address challenges, global challenges, like we just saw in Guy's presentation. We're all coming to terms with increased disaster impacts, climate change impacts. And so really having open community-based standards allows us to share data, and making it cloud native makes it that much more efficient. So collaboration, fair principles, so freely accessible and reusable, all that good stuff. So really it's all about data democratization, automation, governance, supporting analytics, AI, and adaptability. And I probably should think about the 15-second rule that we had in the lightning talks, because I've got a few slides here. So just a little shout out to Michelle from Radiant and Chris, of course, from Planet. So both for organizing the conference, and also they did a joint webinar with us last year. So feel free to check it out. I've got links at the end. I think we're hopefully distributing this deck. If for any reason you have trouble getting a hold of it, fire me an email and I'll send it to you. So yeah, there's a couple. If you just go safe.com/webinars and put cloud native, you'll get the webinars that they co-presented with us. So this is the bit where I don't have to preach to the choir. We all know the benefits of cloud native. Ultimately, it's just optimized for computing on the web in the cloud, and chunking, indexing, tiling. Everything that needs to happen to support partial parallel reads, just so you can read only what you need. And in terms of benefits, I think that was a really good talk yesterday, sort of the so what. The lady near the end of the day. You always have to think about that. What does this actually mean? Because a lot of us can geek out on cool stuff on CN, but what difference does it make? And ultimately, it's about scaling your performance, decreasing cost for data providers, and in sometimes cases consumers, and efficiently handling large data volumes. So this is just what it looks like in the FME platform. I found this cool. I'm from Canada. We're based in Vancouver. I found a data set provided by Natural Resources Canada of a DEM for the whole country. The URL there, I say in my notes, don't drop it into your browser because it'll take a couple hours. But if you just drop it into our COG reader, it'll default to the highest, lowest res pyramid level, and then you just get the whole data set. And then if you drill in and give it an extents or pyramid level 1, then you go from a 16-kilometer resolution down to, 30 meters, I guess. That's for the Fraser Valley. Another shot of Vancouver. So these are just some of the formats that we support. I'm not a sales guy, don't worry, I'm not trying to pitch anything. It's more, I'm a product manager, I'm here to listen. So if there's something we don't support yet, let me know. Or if you've tried out any of our stuff and you have a complaint, it doesn't perform as advertised, let me know. I will just make a note about 24.1. So when I last gave a related presentation, there was a problem with our ZAR, and when I was using it in one of the pilots, it just wasn't, it would do the XY extents, but it wasn't doing the band range properly, and it was reading too much. So we got that fixed. So, and currently we're working on Google Protobuf, if anybody cares about Google. Yeah, so a range of raster, point cloud, data cube, and stack. Yeah, so we'll just run through these quick. You guys all know this stuff probably better than me, so I'm not going to go through in a lot of detail. Basically, you can read stack elements, like the collections and the collection elements, because sometimes what you want to do is just read the metadata and decide, based on the metadata, what processing to do. In other cases, you want to actually retrieve the asset. And this was an interesting deployment. We have a thing called FME Hub. We have people in our user community who post stuff to our hub. So it's not all by us. And this is how we chose to deploy Stack. And that's because I guess when we were deploying it, there were a lot of changes and updates that we were making. And so even though we kind of have major releases 2 or 3 times a year, we have dot releases, we wanted to do more of a continuous deployment. So if there's a change or an enhancement to Stack, we can just change it on our hub, and the next time you'll get a notice if you got a workflow and it's out of date, it'll say, oh, do you want to update? You don't have to, because you can control that. So this is just the whole chain of drilling through this Canadian on AWS S3, some spot imagery from Canada, and drilling into the actual asset. In this particular example here, all I'm doing is reading a bunch of regular geotiffs, converting them to COG, reprojecting them, combining raster bands, and then writing them up to S3 with our S3 connector. I think we're setting a no data value as well. So I'm just mentioning that first off, just to show you, yeah, this is what an FME workflow looks like. So there's no code, you just drag and drop. Sometimes you have to configure stuff. The other thing is the people who do know FME, they know us about doing stuff like converting from CAD to GIS, and working with vector data. But we actually have a pretty sophisticated tool set working with raster or multidimensional raster. So that's just a little video. Keep an eye on the time. So yeah, just to summarize, I think I've already covered that. So just a little bit more about COG, partial read, min-max, extents, clipping, and so, yeah, an ideal, like that Canadian example, you've got a huge data set, you just want to drill into what you need for a project area. Just a word about the writer. So we have a COG reader, but the writer, you actually have to set layout as cloud optimized tiles. There's just some FME specific stuff in terms of how to configure it. Yeah, and I think I've covered this enough. So this one was kind of neat because it used COG as the source, and it just created a wildfire report for West Kelowna. So that area in the interior of British Columbia gets a lot of wildfire. And so we just made a HTML report, and we were able to choose the pyramid level and the extent for each of those thumbnails, and then spin out this report, which of course anybody with a web client could just review that. If they wanted the full resolution, they could just click on that resource link. And again, it would just be for the extents around that fire. So the thumbnail is a bit lower, smaller and lower res. Yeah, it's using an XML templater to build. So not only do we read and write geospatial data, we can work with tabular data, PDFs, web stuff like output HTML tables or web scrape. So moving on to vector. So a lot of this conference, I would say probably 3/4 it seems to be people are working with raster data cubes. So it's not totally clear to me which who's going to win the war on the vector side for cloud native. We hear a lot about GeoParquet, but FlatGeobuf has its advantages. It is got maybe better spatial indexing. FlatGeobuf doesn't natively have any. So I'm not going to spend a ton of time on this. This is just uploading a bunch of FlatGeobuf data to S3. And I think it's using our FME Flow platform. So we have FME Form, which is our desktop product where you can author workflows and then you can publish it to Flow. So in this case, you wouldn't have to have FME installed. You could just have a web browser. You could grab your data, your vector data, throw it in the, on the web form, and it would upload it, convert it to FlatGeobuf, and then perhaps list it in a catalog somewhere. So I mentioned GeoParquet. That does seem to be, I guess it's been around longer and it's just more pervasive in the community. There's tons of libraries and apps for Parquet. Chris seems to be a big fan of GeoParquet, so that's probably helping it a lot. Column-oriented just handles huge volumes of columnar data, and it's it's expanding. I just heard at this conference, Parquet is getting geo built in to a certain extent, so it's still developing. So this is just basically doing a performance demo. So this is, again, this is kind of probably old hat for some of you, but I think it doesn't hurt to emphasize, no matter what tool set you're working with, try to test the range of representative configurations, because sometimes you may have a favorite architecture, but it may not fit your customer's data. So in this particular case, I got a bunch of OSM data, or sorry, a bunch of vector data, loaded that up. It's about 1 million records of water areas, and basically I loaded that up into OSM, GeoPackage, regular Parquet, GeoParquet, and then partitioned GeoParquet. And you'll notice that on the bottom right there, you can, if you do want to partition GeoParquet when you write it, you have to specify what attribute you're gonna, like what category or attribute you're gonna partition on, and that will improve your performance. So that's just a snapshot of what the data looks like. I think it's flood polygons. And so this is just comparing local access, S3 to local, and S3 to, so cloud to cloud. So basically on-prem only, cloud to prem, and cloud to cloud. And so when I just used straight up regular OSM, it takes about a minute to read it from cloud to local. It takes about a minute and a half to read the GeoPackage, 30 odd seconds for the unpartitioned GeoParquet, and about 15 seconds when it's partitioned. And obviously cloud to cloud is way faster. So it was just an exercise in testing performance. And of course you can use DuckDB, and I have an example of that later. This presentation isn't about cloud databases. I just threw a bunch of them up here just so you have a sense of who we work with. So obviously not everything is going to be a CN file or stack. There's lots of other cloud data out there. So just a quick one on COPC. I don't even know if this is Copic or I just say COPC. Based on the last standard, the whole idea here is you can have billions of points. You just want to query an X, Y, Z, min, max. And I have to actually double check if we do the Z, min, max. Because most of the data we encounter our customers use tend to be terrestrial. But yeah, that's a good one to double check. So like one of the talks I heard yesterday, outside of work, I spent more than a decade volunteering for Marine Search and Rescue. That's a different kind of SAR than we talk about here. And so we had a big storm that basically broke the pier, and so they asked me to fly some drone off that. I used OpenDroneMap and dense point matching to get a point cloud out of it, about a little over 1 million points. So I decided, okay, let's just load that up into COPC. And once we had it in COPC, then put it on S3, uploaded S3 bucket, and then I have an FME workflow here that actually reads the COPC, and then what it does is classifies the raster, kind of filters out anything that's the ground surface or the benthic surface, and then it does a raster to polygon conversion so we can do a sort of a post-damage assessment. So I'm just measuring the amount of the pier. There's about 50 meters of pier that got knocked out. So that's that example. So we're kind of winding down. ZAR is one of the last ones I'm going to talk about. Does seem to be getting a bit of groundswell of support, I'm happy to see. Really big for the weather and climate crowd, clearly. So it's basically multi-dimensional raster, usually numeric raster. And what we wanted to be able to do is query that X, Y, and band extent. So you could have, hundreds of gigabytes of data, but you just want the data for this resort area at a certain time step, a certain range. So this is just a straight up conversion from netCDF to ZAR. And because they're both arrays, we just treat them as arrays. It's not like we have to go through and read pixel by pixel. We just basically do block by block, move it across. So it's quite efficient. And I'll get into the OGC stuff in a minute, but I did work with some climate model data from a thread server for the Manitoba area, and this is just looking at some temperature analysis and extracting some point values so we can use them in downstream queries. Yeah, I'll skip ahead because I've got a better example in a minute. So yeah, multi-dimensional array, similar to netCDF or HDF data cubes, but cloud native because you can put huge data sets up on S3 and just read what you need. A little footnote to anybody who's an FME user. We have this handy thing called feature cache that lets you inspect your data at any point in the flow. Turn that off because if you're dealing with huge data cubes, it's going to try to cache everything. So that's a bit of a watch out for that one. I think by default it's off, so it's not going to break by default. Okay, so we're going to deal with some applications, and let me just check what time I got. Still got, not running out yet. So this is a partner of ours, Tensing. They're based in Netherlands, and they also work in the UK. So they had a project. They worked with the Eastern Power Network, a vectorization project. And so this is one of their data portals where they offer data in CSV, Excel, and they also offer it in FlatGeobuf and Parquet. So he just put together a quick tutorial. You can follow that link and get all the details, and he has basically all the SQL and everything that he used to put that together. So this is essentially just an integration between DuckDB and GeoParquet. So he's integrating with Overture Maps, which of course Overture Maps places has more than 50 million place points. So you have to write kind of smart queries. He just wanted to find out, well, that electric grid data set had charging stations. So he just wanted to find out which charging stations kind of had the closest coffee shops. So it's kind of a random scenario. And then basically there's an FME workflow which reads the GeoParquet for the charging stations, and then it uses a neighbor finder, but it writes, there's a SQL query executed on DuckDB which just returns the places in that area. So there's a bounding box and a place type, just so we can filter those 50 million points down. Turns out there's lots of Costa coffee there. Okay, so that's shifting gears now. I'm going to talk a bit about OGC. We're big fans, and I think it's a great community to be a part of. I think the next meeting is in Mexico, but there is one in the fall in Boulder, so it's not too far off. So they've had a big emphasis on climate resilience and disaster management, disaster response. So they've run a number of pilots on that. And in this particular one, Yeah, we partnered with Natural Resources Canada, the province of Manitoba, and NOAA and others were involved. So I won't get into too much detail here other than, because you can read about this stuff online. We were interested to look at, okay, how can we basically downscale climate impacts to the local level? And this is not meant to be any kind of predictive model. This is just more experimenting with the tooling and seeing what's possible and just finding out where are the gaps in the processing and the functionality where we can improve our tools. And so the general idea is we retrieve multiple variables out of the climate model output. Initially, we load everything up into ZAR so that it's faster to access, and then we can play with it. And then ultimately, we want to combine those variables in such a way as to maybe tease out which areas are prone to drought, things like that. Maybe heat risk or drought risk. So here's one question I was asking. So what areas are 25% drier than the historical mean, and the monthly temperature is greater than an absolute value of 23C? And so we were able to basically take the NetCDF and ZAR, query that data, and then how we did that at the pixel level is we figured out the precipitation historical mean by taking 50 years and just averaging at each monthly time step for every pixel over 50 years. And then we just take the future precipitation scenario, divide it by that, and that gives you a normalized value where 1 is the same as historical, 0.5 is 50%, 1.5 is 50% more. So using that, we were able to run this query, and we're querying several million cells, and ultimately we get these, we have a couple hundred points of these. Seems to be the drought area, at least for that particular climate run, climate projection run. This seems to be the area where we're going to have drought in 25 years. So then in the last disaster pilot we ran last year, this is the one that ties into New York. Slight shift in focus, so we dealt with different regions. So this was New York City and Taiwan and a few other areas. So we were focused on the last point, extreme heat. And so the challenge here is that while on the news you're going to see a lot more about earthquakes and floods, hurricanes, because they're more dramatic and they do real damage, but in terms of the picture, it's more dramatic, the impact. They may do more property damage, but in terms of human life, heat is the biggest killer, I guess you could say. So, and one of the areas where we're seeing the most extreme heat is in urban areas because of the artificial surfaces. They absorb more heat and they retain more heat. So that's what this whole pilot was about. There was, we worked with, this wasn't just us, there was a whole team, and Climate Central and others that we consulted. So there were people on the team that kind of queried the scientific literature, and then we just kind of plowed everything into the model. And the basic idea here, again, this is not meant to be predictive, it's more, what can we use in terms of local information to provide, like what's possible technically, and that we can then calibrate in the future to give more focused weather alerts. Because right now, like in New York City, you get a weather alert for basically the city will get one weather alert if it's going to be extreme, but it doesn't vary based on your neighborhood. And often the weather sensors are like in the middle of Central Park because they don't want it to be distorted by the artificial landscape. Well, that artificial landscape is actually what gives you the risk. So what we did was we used the New York City open data that Guy mentioned, and we had very high resolution surface data, and then we used that, we used the literature to figure out what the albedo was for that. We inverted that to make it into an absorption grid. Well, first of all, we converted that to a grid. It's sort of like a 5-meter grid. Inverted that to an absorption grid, multiplied it by cooling, normalized it, scaled it by the observed temperature range, and then generated some outputs like COG. So that's the vector data that kicked this whole thing off, and so there's different surface types and the albedo values from New York City Open. That's the raster math that we're doing, and in the webinar we have, you can download this stuff if you're curious about it. So basically, yeah, the inversion, multiplication, and normalization. And this is kind of what the outputs look like. So that's a color ramp from cool to hot. And you can see the north end of Central Park has almost no temperature delta, but the built up areas that are far from, green spaces get a lot hotter. So we just have one or two quick movies here. I'm almost done. So these are just the sequence of grids. We use COG. I could see probably this might be better in ZAR, but the partner we were working with needed something GeoTIFF compatible. So yeah, I always have trouble getting that slide there. So the partner, this Navteca folks, they used Unreal to render, so do a 3D rendering of this over time with the sort of the sun. So you get a sense of, with respect to where the water areas are and Central Park, where is it going to be the hottest? And again, we would really need to calibrate this because we've only calibrated it with a general value of, the hottest area in the city was 11 degrees hotter. If we had a variable calibration surface, it would be more accurate. So there's a lot more work you could do on that. Okay, so I'm not going to spend too much more time. I think I'm pretty much getting close to coffee time here. So I just wanted to mention here that we do integrate with a variety of cloud services, whether it's not just AWS, but Azure, Google Cloud, and we had this integration with BigQuery that we did a year or two ago. So yeah, just to wrap up, some things, our basic integration strategy, I like what I've heard so far today. I was at a talk just before this where people were somebody asked, well, why was it partitioned that way and why do you have to repartition it? And it was like, well, maybe the partitioning just depends on the application. But I like the idea of just get stuff published, put stuff up there. That's the best way to learn. Obviously, you have to keep the processing close to the data, minimize your traffic footprint, filter early and often. In our kind of code base, we always do lazy evaluation. So even though it looks like you're reading data and doing a bunch of transformation steps, we only actually read anything for real when we have to. And in many cases, we're just passing links to data. Think carefully about your optimization strategy. So are you dealing with transaction volume or data volume, response time, latency, all that good stuff. We make heavy use of third-party libraries, a lot of open source libraries. So far, we haven't really kicked the tires as much as I would like on CPC ZAR. So some of these newer ones, so we certainly welcome your feedback. And it's just a few other lessons learned. So it's all about publishing data, sort of like a serverless way of publishing data. So it makes it easier to publish and it makes it easier to consume because you just read what you need. There really isn't one size fits all. You'll get people in these debates about which format's better. My idea is, because I work a lot with our customers, start with what the customer has, what they need, and then kind of work backwards from there. Stack is fairly complex, so there's probably a few quirks in security we still have to iron out. COG, COPC, they're probably the most intuitive because it's just X, Y, Z ranges. Jury's still out for GeoParquet. I've seen more at this conference than FlatGeobuf. But I've been impressed with ZAR, how much adoption there is there. I think I've covered most of this. So our strategy is to support the emerging standards. I think we do a pretty good job of supporting hybrid environments, and that doesn't matter if you're talking about multi-vendor, vendor open source, or prem cloud or multi-cloud. So that's really our approach. Is we thrive sort of in that hybrid environment. Yeah. And yeah, I keep pushing open standards and test frequently and often. So this is just a bunch of resources. If you get a hold of the deck, those are related webinars at the top and a bunch of community articles. This is just what our knowledge base looks like. So geospatial cloud native. And we're going to be adding to that some data sources. You guys probably have tons of data, so this was more meant for new users. And I guess all of those are partners of ours. So we work with NASA and USGS and ESA and AWS. And this is just, we're not going to get into AI today, don't worry. But we do integrate with AI as opposed to having our own. That's basically the message on that one. So yeah, the next thing is, like I mentioned, Google Protobuf is coming out, but I would be interested in feedback. Do you think we should support Apache Iceberg? If you want that supported, you can go to that link and vote for it. So we have an ideas page. If we have something that we're missing, put it on the ideas page. If there's something we're missing that's already up there, vote for it. So that's that goes directly into our dev system and helps prioritize development. I've also heard good things about Iceberg, IceChunk, and KerChunk for Czar, because clearly with Czar you need some kind of abstraction layer to organize it. And we have our conference next week in Seattle, so if anybody's from the Northwest, you're welcome. And I think that's all I got. So hopefully didn't put you to sleep. That's my email. It's pretty short. So if you need the deck, or if you have any questions or feedback on what we should or shouldn't do for cloud native, let me know. Any questions?
Yes, questions? I see.
You said you support open standards, and if memory serves, you guys, on a cross-liaison group, you guys also are part and parcel to OMG, or Object Management Group, so you support some of their produced ISO standards where they self-certify. But they also have frameworks. And one useful one is Unified Architecture Framework, known as UAF. Do you guys have any extensions that support that, from, say, modeling tools to Invoke to?
Yeah,
or for modeling or co-simulation or some extension?
I've heard a bit of chatter at OGC about the actual modeling frameworks as an open standard.
Yeah.
And there's a couple of other ones. Those don't sound that familiar, but please send me a link about them and I'll look into it.
Oh, okay.
But it would be, that is certainly sort of a gap right now. Those data transforms, if I could find one here without making you too dizzy. These workflows that you're seeing here, this one going to BigQuery, they're kind of self-documenting in a way, but they're sort of like XML in a text file. It's not like they're locked up, but it would be nice to have an open standard way of describing what is that process flow. Yeah. And so I think that is an existing gap, and it would be great to have. I'm just thinking out loud, if we complied with an open standard, then you could probably get ChatGPT to create these for you, because they would be consumable by AI. Right now, they're not really. I don't think AI.
Yeah, that part of the idea is doing the model-based system architecture to the architecture to the Invoke, so that you can do more automation and expose it to semantic ontologies for AI enablement.
That would be definitely cool. I mean, we're just adding support for JSON schema, so OpenAPI is something that we're supporting. We're adding, we kind of have a whole release next week around data virtualization. We support OpenAPI, and so that just kind of feeds into being able to describe our models in a way. And typically what you'll find on our knowledge base is 95% of all our models, we just give them away. Yeah. We're just selling engine time. And
And does
But
that
for-
list some of those other standards that you couldn't have already put in here too, that you are compatible with as well?
Which other standards?
Like any ISO standard, would those be listed on the knowledge base too? So-
Yeah.
Okay, great.
Yeah,
So
there's
I'll
a
check
lot of
that
the
out.
ISO standards, and I've got a landing page for, FME and OGC where we list all the OGC standards that we support.
Great.
But yeah, I mean, some of us, there's a couple people here from Japan who do 3D building modeling, and that's like City GML and IFC, so.
Gotcha.
There's a whole range of, but we were one of the first platforms to support PostGIS. I think we were the first, actually, so that's more open source than open standards, but,
Sure.
yeah.
Well, thank you. Great presentation.
Yeah, thanks.
Okay, thank you.